In the next slide, I will teach you how to find the minimum point on a quadratic function. So how to find the minimum of a quadratic function. But before I just give you the recipe for finding the minimum point of a quadratic function, let's do an example. So let's pick one concrete quadratic, 3x squared plus 2x plus 1, and let's find the lowest point on the graph of that quadratic. How do we do that? Well, we're going to do that by completing the square. Now you're going to say, well, but isn't the lowest point on a quadratic which opens up the tip of the parabola? The answer is yes, of course. But let's for a moment pretend that we do not have that extra knowledge, and let's just find the minimum point on that curve by completing the square, right? Also, the problem instructs us to complete the square. So anyways, we have to complete the square in order to complete the problem. So we may as well forget our knowledge about the tip of the parabola and just complete the square. So let's do that. So I have my quadratic, 3x squared plus 2x plus 1. I'm completing the square. If you remember, when we complete the square and then there's a leading coefficient, our first task is to factor out the leading coefficient. So when I factor out 3 from 2, I get 1/3. Right? So when I factor out 3 from 2, I get 2 times 1/3. Right? So when I uncover the parentheses, I'm getting 3 times 2/3. The 3 cancels and I'm left with 2. Okay. So now, what do I add and subtract so as to make this into a perfect square, right? I'm trying to complete the square. So what do I add and what do I subtract so as to make this expression here into a perfect square? So how should I select the question mark so as to make that a square? I'm sure you guessed it correctly. I need to take the number that I see here, which is 1/3. I need to square it and I have to add and subtract it. So 1/3 squared minus 1/3 squared. That's what I need to add and subtract. So I'm taking this number 1/3 and I'm squaring it, adding and subtracting it. And as you can see, I've already simplified 1/3 squared to 1/9. Okay? Now, this becomes a perfect square, that is x plus 1/3, the whole thing squared. Now, let's uncover the parentheses a little bit. 3 times negative 1/9, that is negative 1/3. You can uncover the parentheses. And finally, I can combine these two terms to get 2/3. So one more thing, this plus I can rewrite it as minus and minus, and 1 minus negative 1/3, that is 2/3. So my completion of the square is complete. Just a reminder, when we complete the square, we always want to have our standard form of the quadratic, which was a times x minus k squared plus h, right? To complete the square means to rewrite my quadratic into this form. I always want to have a minus here when I complete the square. Okay. Okay, so let's find the minimum point on the graph of our curve. What's that minimum point? What's its x-coordinate? I'm sure you guessed it correctly. The x-coordinate on my minimal point is negative 1/3. And if you remember, that was just the number minus b over 2a, right? We already studied that, but here we did not need to apply our knowledge of the fact that the x-coordinate of the tip of a parabola is at minus b over 2a, because we were asked to complete the square. And because we were asked to complete the square, we didn't need to use any extra knowledge, because the number negative 1/3 just naturally appeared from the computations. It is x, whatever is subtracted from x in the completed square, that's the number we need to put there. And if you remember, we had also a ready-made formula for the tip of the parabola, for the y-coordinate of the tip of our parabola, but we don't need to remember that either, because that number is automatically given for us there. So the minimum point on our parabola is -1/3. Is its x-coordinate, and its y-coordinate is 2/3. Our problem is solved.